Hi, so I'm going to be doing a review of practice test 5 from the SAT, and specifically going over the calculator part of the math, numbers 29, 35, and 36. Now we are on the towards the end of the test section, where the problems are really at a more they're difficult. Because it's going to switch over at the next one to the free response. So number 29, you have to recall some things. So let's recall what we know about the equation of a circle. Now, you may have done this in geometry. You may have done this in Algebra 2. Some have even done it in Algebra 1. The equation of a circle. So remember that a circle has some really important parts. It has a center and it has a radius, and those things we really need to key in on. We also have to remember with a circle that all radiuses are equal, so all the way around they're going to create these nice equal pictures, okay, or line segments. Okay, but the equation of a circle is x minus h squared plus y minus k squared equals r squared. And the center of the circle is HK. Okay, so that's actually important because that tells me if I know my center and I know my radius, I can actually draw a picture of this circle. Well, this circle is not in standard form. So this is standard form. To get it into standard form, we actually have to group parts together. And we have to use the concept that you learned in Algebra 2 called completing the square. So I have to complete the square with x squared plus 20x. So I'm going to take half of 10 and square it. And here I'll put the negative 20 over here, so I'm going to leave room. Take half of 10 and square it, which gives me 100. Whatever I added there, I have to add to the other side. Now I'm going to turn this part. This is a perfect square trinomial you just created. If you completed the square, you need to turn it into the square of a binomial. So to do that, you take the square root of x squared, which is x, you take the square root of 100, which is 10, and you take the sign of the middle term. Okay? All right. The other side, you do half of 8, okay, so plus half of 8, which are 16, which is 8, and square it, which is 64. So this becomes 16y plus 64. Whatever you do to one side, you do to the other. And then you turn this into the square of a binomial, so it would be y plus 8. All right, now we're going to add this all up. I don't need this for this question, but I want to review it. So 164 minus 20 gives me 144. All right, so now I've got the equation of a circle in standard form. So my h is negative 10. My k is negative 8. Notice it's changing the sign because the formula is x minus h. So that tells me that my center is negative 10, negative 8, and there's my answer B. But I also want you to recognize then my radius. If this is r squared, then my radius would be 12. So that's how you work with the equation of a circle. Thanks. Let's move on. Okay, definitely a great Algebra 2 and Algebra 1 question using a little bit of geometry, which we love. All right, a landscaper is designing a rectangular garden. The length of the garden is 5 longer than the width. If the area of the garden will be 104 square feet, what will the length in feet of the garden be? All right, so I like to draw pictures of these. So I'm going to draw a picture of a rectangular garden. Now, the thing with these types of questions when we're dealing with area, we need to know the formula. Area is length times width. But if I don't have a length and a width and they're giving me one in terms of the other, I always write my variable in terms of the width, the smaller of the two, because width is smaller than length. And remember, we're trying to write one variable equations. Those are the ones that are easy for us. So if the width is w and the length is 5 longer, then I can say w plus 5 is the length. All right, so if this is my width and then my length is w plus 5 and my area is 104, I can actually write an equation. Length times width equals 104. So w times w plus 5 equals 104. All right, so to make this equation doable, we need to handle this left side and simplify. So we're going to multiply w times w plus 5 and get w squared plus 5w equals 104. This made this a quadratic, right? And we know that the area model does give us quadratic equations. So if it's a quadratic equation, it has to be set equal to 0. So I'm going to subtract the 104. And now I'm going to solve by factoring. All right, so I've got to find the factors, right? So I spent some time doing that, and I went through my factors, and I found them to be 13 and 8. So w plus 13, because I wanted them to add to 5, but multiply to a negative, and w minus 8. Now, this is where you have to be careful. You set each part equal to 0, so we get w equals negative 13 and w equals 8. But the question asks me, what will the length be in feet? This is the width. So to find the length, I have to add 5. So the length would be 13. And that would be the answer. And this is a free response question, so no multiple choice for you to choose from. Okay? All right, the last one I'm going to go over from this set is a great picture. Another one of those circle questions. So I'm kind of nice that we went over circles. All right, so some things you need to also remember about a circle is a circle, when I was looking for x, this is called a central angle. An angle created with the center, x, is a central angle, and its measure is equal to the measure of its arc. So if this arc was like 50 degrees, then this arc would be 50 degrees. Circles also have another really great angle. It's called an inscribed angle. An inscribed angle, let me make that go to here. An inscribed angle is an angle whose vertex is on the circle. So look at the difference. And its measure is always half the central angle. So in this case, it would be 25. That idea right there was something that was really helpful if you wanted to do number 36. So what I saw was that angle A, was if I could find angle A, then I could find angle X. And what I did do was I drew a radius from A to P. The reason that helped me is that I knew that these then would be equal, and I created an isosceles triangle, which makes this angle right here 20, and which makes this angle right here 20, because those are congruent triangles. So the inscribed angle is 40 degrees, which makes the central angle 80 degrees. Again, an inscribed angle is half the measure of a central angle, and that's an important fact for you to know from geometry. All right, guys, that's it for today. Have a great day.